The last thing in our molarity kind of unit is understanding how we can find some unknown molarity. So one helpful thing is if we're titrating between an acid and a base. So if we had something like a very strong base, NaOH plus HCl. So both of these are aqueous solutions when you put them in water. So when you put them in water, what's going to happen is you're going to get sodium, you're going to get hydroxyl groups, you're going to get hydrogen, and then you're going to get chloride. So all these things are going to be mixing together. Well, you know what? Sodium and chlorine are pretty happy as ions. They're just going to be. But OH minus and H plus are very, very unhappy. This is what makes a base, and this is what makes an acid an acid. Because it's so unhappy at being at H plus, it's going to try to find either electron or a partner to pair up with. Same thing with OH minus. It's very unhappy as OH minus, so it's going to start attacking other molecules around it. So that's why bases and acids are dangerous, because if you have enough concentration of H plus or enough concentration of OH minus, it's going to start attacking things or molecules or skin or metal, whatever. It's going to try to get that electron or give away that electron any way it can. So what happens when you have them together? Then you get a neutralization reaction. What's going to happen is H plus and OH is going to find each other and go, hey, I need to get an extra proton, I need to get more electrons, and they get happy and they come together and they come together as HOH. And then you have Na plus and Cl minus. So they're going to be happy in the solution. H2H is pretty much just H2O. So when you add an acid and a base together, you just get water and a salt. So that's why is it called a neutralization reaction, because you're adding the two together. Let's say you had an unknown concentration of one of them. Let's say NaOH, the concentration is unknown. But you want to find out what that concentration is, so you're going to add a known concentration of HCl. And when you add them together, what you're looking for is when it's finally all neutralized. When you have the equal amounts of OH reacting with H plus, then instead of being basic or acidic, you're just going to get a neutral reaction. So what we did in class is we had an unknown base. I think we had an unknown acid, but it doesn't really matter. So here is our NaOH with the unknown molarity. And we're going to put some indicator inside. And that indicator stayed. Which way did we go? Oh, we did do unknown base. Indicators should be blue when it's basic. And once it's acidic, it's going to turn yellow. And our goal is to find that point which was not really a base, not really an acid, so it was kind of like that green color, and we try to get it. So that was our titration, and we titrated from a Buret. So a Buret is a cool instrument. It looks like a long graduated cylinder. The weird thing is that the zero's on top, and usually it's the 50, so this is a 50 mil Buret on the bottom. So ideally you fill it up to 0, and then when you open up the nozzle, so remember when it's parallel, this is open. When it's perpendicular, this is closed. So when you open it up, the liquid's going to fall out, and then it's slowly going to go down. So it's going to tell you how much of it drained out when you stop it. So it goes from 0, and let's say you put out 10, it's going to drop down to 10 marking. Now in reality, it's really a pain to fill it up to 0 every time, because 0 is pretty much at the very top. Normally we have a funnel up here so we don't spill, and the funnel kind of goes down to here. So ideally you're not even going to fill it all the way up to the top because the funnel's in the way. So we could just subtract the initial with the final and get the same kind of answer. So that's what we did in class. It was a neutralization reaction. We had an indicator in the base, and we dripped down HCl until this became neutral, and then we compared the volumes of the two. So that's what we did. So we're going to do kind of that kind of thing. So let's say here is my Buret. I'm going to make up a number here. Let's say this was 12 milliliters, and here is the Buret. Here is the nozzle. Right now it's closed. Here is my beaker of an unknown solution of NaOH. We don't know the concentration, but we want to find out the concentration. But I do know I poured out, let's say, 30 milliliters of it. All right, so I have 30 milliliters of unknown concentration of NaOH. I have a known concentration of HCl. Let's say it is 0.22 molarity. And I want to find out what this concentration is. So we're going to do a titration. I'm going to open this up, and then liquid's going to fall in. And let's say it drips all the way down to right here, which instead of 12, now it's, let's say, I'm going to just make up a number, 32.1. All right. So how do we solve this? Well, it's just a MV equal MV. Again, it's very similar to the dilution one. We want to compare the amount of moles in one with the amount of moles in another one. So this is MV of A, MV of B, and we're going to compare the two. So we know this one. This is a 0.22 molarity solution of HCl, and the volume is the difference between these two. So let's say it was 12.0. I want to save my sig figs. So 32.1 minus 12.0. Bust out the calculator. 32.1 minus 12. And I get 20.1 milliliters. All right. Now, on this side, I know I have an unknown molarity, but I do know the volume, 30, and I'm going to put one more sig fig just so my answer is a little bit better, 30 mil. Now, you really should convert these to liters. That's kind of what will work, but you could kind of get away with not doing it, because how would you convert milliliters to liters? Well, you have 1 liter on top, 1,000 milliliters on bottom. And you multiply across. In this case, you divide. So I'm dividing 1,000 from this. Now, if I divide 1,000 from both sides, it kind of cancels out. So you could cheat on this one or be lazy and leave it as milliliters. As long as it's milliliters on both sides, you'll be able to be okay. Now, if it's liters on one side, then you need to convert the other side to liters. But in this case, you kind of get away with it. So if it took 20.1 milliliters of 0.22 HCl to dilute this, I could find the molarity of this one. And all I have to do is isolate M. So I'm going to get rid of the 1,000 because I want to be lazy. So all I have to do is divide both sides by 30. So 0.22, 20.1 divided by 30.0 will give me my molarity. So 0.22 times 20.1 divided by 30. So I get a 0.1474 answer. This has 2 sig figs. I'm going to round it to right there. So the molarity of my base is 0.15 M of NaOH. And that's how it's done. It's very simple. In the case of math-wise, it's just MV equals MV. It's just understanding what you're doing here. So that's kind of what we did with titration, and how you could find an unknown solution based on that.